welcome back to the channel. If you're new here, my name's Brian, and this is a Dyna-Glo 208 to 240 volt electric heater. So today on this shithole, we're going to try to install this bad boy. I've got this older one up here right now, but she basically breathes out about a warm fart, and that's really about all she does. So I kind of want to see. I feel like this one's going to work better. I'm probably just pissing in the wind at this point, but you know, 150 bucks at the Menards should be all right. Either way, it'll have a thermostat and a switch, whereas this one has a little knob on the front that doesn't do jack fucking shit, and to control it, I have to turn on and off the circuit breaker, which just seems stupid. All in all, this little heater has actually done pretty well, but if it gets really good and cold out there, and if I don't warm up this garage every couple days, it just falls to a point where this thing just can't keep up. So I'm hoping that maybe this one will work a little better, and then chances are I'll end up using that for some other project later, because I never throw anything away. I mean, you can see this is just bad, right? So got me a cold snack, move some few things around, and see what we can do to make this disaster work, and how to wire it up and all that bullshit. Alright, so I got you all in here. As you can see, this is that thermostat knob I was talking about. It does nothing. And it's blowing out some decently warm air, but not great. So I'm just going to open up this rusty bottom here. It looks like it's just a wood screw crammed in here. That's totally right, I'm sure. And then we'll just kind of pop this bottom on open. Oh, yes. So you can see this is really technical in here. So yeah, I guess I should shut the breaker off, and then we'll get these wires disconnected out of here and get a look at the new one. In fact, you know what? Why don't I leave it running, and let's take a closer look at the new one. Let's unbox this bad boy and take a look at what we got here. So I'll just move you guys right here so you can kind of see what we're working with on the project table. Just move this out of the way. So just grab this box here. Alright. So let's see what we got in here, huh? Just set some things out of the way. There we go. Use my safety box cutter, also known as a Chrysler key. Now even I can't hurt myself with that. All right. Looks like we got some closed cell styrofoam in here. Whoop. Okay. Well. Yes, no, maybe. Not quite. Something like this, huh? Weasel it on out of here. All right. All right, we've got some instrucciones. We got a mounting bar with some hardware. Let's get a look at this bad boy here. Obviously, this should be a hardwired unit like the one I've got, so it's not like there's going to be any plug or anything for that. Grab the safety box cutter here. There we go. Looks like she's got a heater's thermostat or external thermostat, so they got to control this switch back and forth. So that's kind of nice. On the front here, there we got our nice mechanical thermostat and a 7500 watt or 5000 watt control. So that's nice. A couple of Phillips screws. Maybe this just swings down like the other one. Okay, it's machine thread. Oh, yeah. Oh, look at that. All right. Gorgeous. Looks like we got a relay mechanism here for the heating elements. And then I see line 1 and line 2. And then this must be for the external thermostat, I'm guessing right here. Take a look at the instructions to know for sure. But yeah, this looks pretty straightforward. Looks like we'll have the power coming through the side here based on where these are. There's no hole in the back. So we'll knock one of these little knockout plugs out and take a peek. So I'm going to take a peek at the instrucciones and just make sure I'm on the right path here. So it looks like according to the wiring schematic here, you've got, just like we figured here, you got line 1 and line 2 for your loads to make your 208 to 240 volts AC. And then the number 1 and number 2 are for the external thermostat, which we're not currently going to be running. I doubt that this thing would work good enough to have a reason to have an external thermostat, but simple enough 2-wire installation to make that happen. So yeah, first things first is we'll get the old one pulled down and then get the new one mounted and get it wired in. Let's see what happens. So pretty straightforward here. I've shut the breaker off and I'm going to go ahead and get this wiring pulled out. We've simply got a black and a white for our 2 hots, and then a simple ground connection. Now, normally I think on most 240 circuits you'll have a black and I believe it's a blue, and then you'll have a white as well for the neutral. Like on 110 circuits, your black is your hot, that's where all the load is coming, and the white is the neutral. But when you go back into the circuit breaker box, the white is actually meeting up with ground anyways. And the way this thing appeared to be wired, that's all it really needed. So I just did the same thing. I just ran the ground in and then the 2 hots, because it's on a double breaker, to give me the 240 volts or whatever it is that we have here. And I should actually take a measurement and see what my voltage is, because I don't remember. And I mean, if I'm only getting 208 volts, I'm never going to get the 7,500 watts out of it that it's rated for. And knowing my luck, that's going to be exactly the case. But hopefully, being a much newer, what appears to be a better designed heater, I'll still get better heat out of it than I was getting out of this old girl. This old girl was great. I mean, I got it for free from my boss. It was very nice of him to give it to me. He actually had this thing running on 110, and obviously that really doesn't do shit. So we got the wiring pulled out, and we're just going to go ahead and close this up for now and put that wood screw back in. That's perfect. So we'll get this guy pulled down. He's mounted up pretty straightforward. We've just got a couple of bolts on either side, and then this is just screwed to the 2x4 up there. This heater didn't even have a mount when I got it, so this metal piece here is a part off of a riding lawnmower, just some scrap steel that I saved. So you see this a square cut hole there for a carriage bolt, and I just kind of welded it together. And I mean, hey, it's worked great for, you know, the 2 years that I've been running it here like this, so, you know, that it ain't really all that bad. And I mean, honestly, it's just 2 wood screws holding it up there. So I'm going to get this bad boy yanked down, and we're going to go from there. I just pulled the screws out, and literally, I think the stickiness of the spray paint is the only thing that's holding that up there right now. And this is a couple pounds worth of steel. So, I mean, that's pretty good, really. Just the fact that it was sticking up there that well. So, before we slap the other one up there, we'll do a little bit of a side-by-side comparison and take a look at the differences between these units. So looking at these two side by side, I'm not seeing what's gonna be a whole heck of a lot of difference, really. All the more reason I'm thinking it's probably just gonna be a piston in the wind as far as if it's a better product or not. They are actually really quite similar. I honestly thought this one had a better style heating coil, a round style one or something, but I think that was a different model that was more expensive. This has the same setup with 6 tubes that have the heating element wire in them, and the exact same kind of design here with the 6. Fan blade looks like the same 5-blade fan blade. Going onto the back here, same scenario. little bit of a smaller permanent magnet motor. Otherwise, all in all, these are very, very similar. You know, I'm not sure the brand of this, but judging by how similar these units are, I can't help but think that this may well be a Dyna-Glo unit as well. Let's flip these over on their side, open up the backs, and just take a look at the wiring underneath side by side and just kind of see what we're seeing. So looking inside the bottom of the new one here, we'll go ahead and turn this light on for a little assistance. All right. What I'm seeing here seems to be fairly obvious. We actually have what appears to be 3 separate hot lines and then 3 separate neutrals going to either side, as well as a ground for the coil control. And then there is a little thermostatic switch here, is presumably a safety where it's not going to turn on unless if there's enough heat inside the box. I know there is a similar safety on the other. Otherwise, I mean, it's a fairly simple setup, fairly simple thermostatic wiring. This relay module is interesting. I can't say that I know enough of quite what's going on here. Presumably it must be a low feed for that thermostat, which would normally you would have some sort of transformer that would be dialing down the power, like on a household HVAC system. You have a transformer that would dial it down to 24 volts AC for operating things like the relay and whatnot. So that's kind of interesting. I also noticed that we actually have some neon tube indicators, so that's kind of cool. It's kind of old school. They run on the 110 volts directly. So, oh, you know what? That's an overheat protection. This is actually set up where if the box gets too hot because the fan is not operating, I can see that these wires are running from here to the red indicator for a warning of sorts. On this one here, obviously quite a lot simpler on the inside. I'm not exactly sure all what's going on. I mean, I can tell you that we have some returns here, and whatever this orange wire is, it's going to the, actually it's going to a load side. So they almost return just to the chassis. And then I've got 4 wires coming up here, and they're all bridged together as well. So it's kind of interesting. I'm not really sure quite what's going on here. It looks like one load side goes here. So, and I mean, it's entirely possible that this thing was never quite wired up right to make it operate correctly. I'd have to take some time to study this diagram more. It's definitely quite a bit going on. I do know that this system does have a thermostatic switch right on the inside there that doesn't even kick the fan on unless if there's enough heat. So when you first turn the breakers on, and I can see there's a blue wire on it, this thing will warm up the element a bit before the fan even kicks on. So interesting. Looks like a bit of a difference in the way they're designed. Brand name wise, I am not actually seeing anything that is denoting the brand name of this unit. So that's a really good question. I get the feeling it's a Dyna-Glo based on the various similarities here, but I'm really not sure. So I guess at this point, the next step is we're going to get this new bracket mounted up here. We'll get the wires in through, through this side. We'll punch this little hole out. And then we'll get her fired up and kind of see what happens. So as far as mounting hardware is concerned, they give us 3 rather beefy lag bolts to go through the 3 possible holes in this bracket. Probably important for ceiling mounting and stuff. And this unit is not really that heavy. And of course I'm just mounting it to this 2x4 shelf, which I've got, I never cut the extra off, but I've got it pretty sturdily supported. And the previous one was literally just being held together with 2 little wood screws. So I'm going to do this the right way and just use one. And I'm just going to go ahead and pilot a hole right where I had the other one mounted. And maybe a little more, just for good measure. 1/4 inch drill bit, which is probably a little too small. But I'd like it to have plenty to get a hold of. And of course, we're going to install the bracket the easy way. And just kind of ram her up here. Give her the old ramrod. Oh, see? That's perfect. And now it can even rotate. I mean, it's better than my last one, clearly. So the next step then is going to be hoisting this bad boy up here and locking it in place with these, I can't even think of the name. Thumb spinny bolts, something, whatever. Details. Details. So we're just going to get this bad chicken up here. Got one in, and then grab the other one. That looks pretty decent. Before I lock these down, I'll put these other smaller ones in. They have little pivoting. They show in the manual that you can actually run this at more of an angle if you want. I think in this case, having it straight up and just adjusting these fins is probably going to work pretty good for the way I have this set up in here. So we'll just spin those in and snug those down. And then she wiggles, but she ain't going nowhere. Pretty safe to say that I don't think it's going anywhere. And then these little guys will just, probably should have done it what was on my little workbench, but you know, there we go. They can still come out pretty easy. So this way then I can get my wiring and feed that right in through a hole on the side. And I think what we'll do is, actually these are pretty straight already as they are. What about the ground? Where are we connected to? Looks like they've got a bolt right here in the chassis to use for the ground connection. And it looks like a 10 mil, maybe it's 3/8. It's actually 10 mil, but I got the 3/8 on there. So I think I'll grab a 10 mil socket for that, but let's get this hooked up, put power to it, take a measurement, and find out what our actual voltage is before turning it on, and maybe even see what the voltage is with it running, if it's dropping down, or, you know, I mean, this wiring probably not thick enough technically, but I mean, I do everything correctly. All right, so of course, before we get the wiring hooked up, we're going to want to get our little nut in place here for this little clamp that holds the wiring in place. Once again, I'm not entirely sure what its proper name is. And we're just going to spin that nut on there. And we're going to spin the nut. Come on. Shouldn't really cross thread that easily, you wouldn't think, right? Christ's sakes. There we go. Spin that on there. And I know one little trick of the trade, if not pliers, is just to use the screwdriver and kind of use that to tighten it up. That's pretty good. And then we can get these wires in place. So I'm gonna get the ground wire on here, and I grabbed a 10 mil because apparently, sure enough, it's a metric fastener. I was kind of surprised at that. Snug that up. That way we've got our ground / return. And then these, we've just got little pinch connections, so those are pretty straightforward. We'll just loosen a couple of those up with our straight blade here. Just like the connections in the circuit breaker panel. Loosen this one up. Loosen it up some more. Come on now. There we go. We're going to shove our black wire into line 1. Which I don't know if it really matters, to be honest, if one of them should be in line 1 versus line 2, but my thought process here is, well, on a 110 volt system, the black wire is the load wire anyways, so I would consider that load 1. And it is just being a butt, but there we go. Just got it shoved in there a bit. And then I can snug that down. Snug it down. Come on now. Not that hard. And then let's get line 2 in here. And these solid copper wires, I mean, you gotta kind of bend them around and stuff, which ain't bad. It's just, but it does fight you in a small space, that's for sure. And whether or not you got the screw loose enough, too bad. Maybe I'll loosen that up a tiny bit more. It might go in a little easier, you know. So make sure it's in as far as I can get it. There we go. Tighten that up. Well, don't back out now. Come on. There we go. All right. And then I'm just going to tighten up this clamp that holds the wiring in place. Less concerned that it's going to, you know, pop out or anything. I'm just going to kind of fold this wire back here a little bit. So now, let's grab a multimeter and turn the breakers on and see if we let any smoke out of this thing. All right, so moment of truth here. Thermostat is all the way down, and I hear a click, so it makes me think it's off. We're just going to flip the breaker on. I don't see any smoke. I see the little power lights on. So I'm just going to take a look at it with our voltmeter here. We're going to put her to Dirty Deeds Done Dirt Cheap. It's currently on the Dirt Cheap flavor, so we're going to put her over to the AC flavor. And then we're just going to go ahead and put one on the load. Oops. Come on now. Interestingly enough, we're reading 10 volts, and I'm not even connected to the other side. It's almost like power going through the air. So we have 236.7.6 volts, something like that. That's pretty good. I mean, that's pretty close to 240. I'm going to be honest, I'm kind of surprised at that. So I'm going to turn the thermostat up a little bit now and see what happens. Oh, there's that click of that relay. And she's a chooching. Starting to feel a little bit of warm air. Let's see if we can get a reading with it running and see what the AC voltage is at. 225. So she went down a few volts with a load. But I can tell you right now, it is pumping out more heat than the other one did. Just by the feeling of it. In a sense, less airflow. Like the other one was spinning the fan a bit faster. So that could attribute to what felt like less heat. But this genuinely does feel like it's putting out more heat. So that's kind of interesting. And then, so if we put it to 5,000. Yeah, the fan did pick up a little bit there. Well, we want all the chooches. So let's turn this back down. Oh, that thing even moves. Look at that. Let's get in here a little more. It's a physical contactor. How cool is that? I'm not going to fuck it up. But that's pretty neat. So that's a, 110 to 240 volt AC contactor. That's kind of cool. For someone like me who just likes silly things like that, that's pretty sweet. So just put this little screw back in the front here. But yeah, I mean, this is apparently going to be slightly more difficult than it needs to be, but that's okay. We don't, whatever. So yeah, so that's what we got going here now. That this guy's looking pretty good. Just pushing out a nice amount of heat. You know, I honestly get the feeling that this is going to do better than I expected. So, you know, fingers crossed that it wasn't a waste of money. It was only 150 bucks. It ain't too bad. I brought in the old Blue Flame to kind of help get the garage warmed back up. I turned this guy on this morning at about like 11 o'clock. And I had it running until I came in here to start working on this stuff at about 4 o'clock. So you're talking about, what, 5 hours? And it was up to 40 in here, and it's single-digit temperature out today. So, I mean, it wasn't bad. Or honestly, we're shy of 50 still. So, I mean, it's fairly comfortable in here. I can work in here fairly well. I mean, luckily, the nice thing is this garage, you can see the cinder block is up pretty high because we're built into a hill. And I think that genuinely helps a lot. So, you know, I can feel my toes are a little cold, and these are just cheap $15 Walmart shoes because I'm a cheap ass. But, you know, it's not bad. So, hopefully, you know, yeah, I mean, this, honestly, this puts out enough heat that it's uncomfortable to hold your hand here. Like, it's nice for a minute, and then it's like, okay, yep, nope, I'm done, I'm good. So, yeah. I'm not getting shocked when I touch the box. So, I mean, that's good, right? So, well, what do you know? Well, at any rate, thanks for watching. Hopefully, this was somewhat informative or helpful on this Dyna-Glo heater. Once again, I'm sure what I've done as far as installation is nowhere near correct. I'm sure that wiring is too thin. I'm sure it's not correct conductor size by any means, but that's what you're going to find on this channel. You're going to find a lot of hodgepodgery, a bunch of just garbage. And you can take a look at the circuit breaker, for example. I moved into this house and this 220 line was just sticking out, bare wires, and the breakers in the house were on for it. So if you would have grabbed it, you would have gotten quite the tickle. So I just got this panel, and I got it for a really good deal. So I was like, well, fuck it. You know, it's bigger than I need, but whatever. But the power wire was really low. So the power wire is supposed to come in the top. Well, not anymore. She's coming in the bottom. And I've got some lugs behind it to extend the wires to get them up to the top. It's pretty bad, but I mean, it works. You know, I was able to separate all of my circuits in the garage and then have a almost 240 line to run out for the heater. So a lot of really bad jury-rigged projects like that is exactly what you'll find on this channel, as well as some revival stuff here and there. And soon we will be working on this massive project as kind of the next big thing that I want to work on the majority of this winter. So once again, if you made it this far, thank you for watching. Hopefully it was helpful, and may or may not be worth a subscribe, but I don't put out that much content right now, though I'm trying to get a little better with that. And yeah, thanks and have a good day. I just noticed we're getting some glow out of the middle there. Look at that. I sure ain't used to the other heater doing that. Let's turn off the lights here and kind of trip our way over. And yeah, like right in the center where the fan is, where there's just less airflow, we've got some legit glow going on. So yeah, that's a pretty good sign in my book, I gotta tell you.